Assalamualaikum warahmatullahi wabarakatuh. Thank you very much. I would like to present my article in this seminar. The title is Optimization of Stroke Rehabilitation Hand Component of 3D Printing with Taguchi Method Approach. Firstly, I would like to introduce myself. My name is Fatahul Arifin. My partners Mulyadi, Penoria Putri, Iskandar Ismail, and Suparjo. The introduction. The cause of the stroke are different among the countries. We know from the literature the ranking is from 11.6% to 12.7% in North Korea and 9.7% in China and Indonesia. That the rehabilitation is program set to people with physical disabilities or chronic disease, so they can to live or work with their capacity. So they need the device to reduce the therapist's workload, but also have to improve the therapist condition for the patient. The purpose of this research is to obtain 3D printing product that is better in size according to design and strong structure. And this is the research methodology. Design product, then we use Autodesk Inventor, then simply 3D printing process, and making a product. We use the 3D printing, and then the next stage is dimensional measurement, and then hardness test. After we get the data, we process the data using Taguchi method, and finally we get the product. This is the equipment or tools we used in our research. This is the design of our product. That is contain many parts, so we get the dimension of the part. Only one part we measure this study or this research, and we setting the printing, and we get the three position, and we get the time 28 minutes for A position, and 1 hour 2 minutes for B position, 1 hour 57 minutes for C position. This is the INFILL EBCD. This is the HEATBED E and B. And before we continue our experiment, we do the experiment to won't get the processing window. This processing window, we compare the layer height versus print speed, and also print temperature versus print speed, and we get the result for high layer 0.5 until the 0.30, that the product a long time, and the result is rolled. And for the product more than actually for print speed, the product is flexible. Okay, uh, this is our experiment variable layer height for level 1, level 3, level 2, level 3, and fixed variable infill density and heat bed. Dimensional accuracy and hardness test, and we use the equation. The dimensional accuracy is actual part minus design part divided by design part times 100%. And for hardness method equation is 2p divided by p times d and d minus quadrant d 2 minus dr2. Our data processing factor and level layer high E, B, C, and for print speed 20, 30, 40, print temperature 195 to 100 and 5 and 250 for level 1, level 2, and level 3. And the metric orthogonal is L9, 3, 3, 4. This is our experiment result. We use the smaller is better for dimensional accuracy, and larger is better for hardness. And this is the diagram of the dimensional accuracy. We have for A, B, C vector. For A 2, for B is B3, and for C is C1. And also for briefness test, we have for A vector is A2, B vector is B1, and C vector is C2. And this is the confirmation of our experiment for taguchi. Dimensional accuracy is optimal levels is E2, B3, C1. And for the result is for dimensional accuracy is 0.203, and for the hardness is 4.862, and for Brinell hardness number A2, B1, C2. For the value of the experiment is 0.647, and for the hardness is 11.537. And this is our conclusion is the four-dimensional changing is happen in all product 3D printing for many reasons, but the defect can be reduced with the parameter are dominant in this process. And finally, the hardness was not get a accurate number because the error happened during the measuring process. The experimental results support the proposed approach, which not only minimize the dimensional changing of the product of 3D printing but also improve the quality of hardness of the product. Thank you for your attention.